uniform, uniform and non-uniform, non-uniform, uniform load, and UDL, uniformly distributed load, and UVL, varying load, uniformly varying load. UDL, where WC, small w equal to constant. W means intensity of load, intensity of load means load per unit length, load per unit length, and its units is Newton load per meter units. This is constant, UDL, and UVL, the intensity of load is varying with length, varying with length. Next is load diagram. Load distribution diagram. Load distribution diagram for uniformly distributed load, UDL. For UDL, here small w equal to intensity of load versus length, and the diagram is this is W, load per unit length, and the magnitude of UDL, magnitude of UDL equal to W into L, means area of load diagram. This is rectangle, that this L and height is W, the multiply the area of rectangle W into L, that is magnitude of UDL. And it acts passing through the centroid, centroid of the load load distributed diagram, and it acts and it will pass centroid of the load distribution diagram. Centroid, pass through centroid, of LDD, মানে load distribution diagram, where centroid is L by 2. Load distribution diagram for UVL, uniformly varying loads. This is W, small w, and a length. This is uniformly varying load diagram. Suppose there is 5 bricks on the floor. Sorry. One, two, three, 5 bricks on the floor, and then 4 bricks on this brick, some 3, 2. This is uniformly varying loads, linear, and the magnitude of UVL. This is small w0 bound small w naught, and this is a triangle. So the area of load distribution diagram is the magnitude of UVL. Now W half into the small w naught into L, and its centroid from here. This is L. Total length is L. From here, from origin 12/3 is centroid, half into W naught L. This is very important for SFD and BMD shear force diagram and bending moment diagram. Now shear force, SF. Shear force. What is shear force? For loading SF. Shear force at any section is the summation of all transverse, means vertical, all transverse loads up to the section, shear force up to the section. Suppose this is beam, and takes from there, from left side up to section, summation of transverse loads is called shear force at the section. What is bending moment? Bending moment at any section is a summation of is the summation of moment of all transverse load up to the section. Means, suppose this is beam and there is a one moment, and there is a reaction force, and takes summation of, here is the distance and force create a moment, and this is moment, summation of the moments up to this section. This is bending moment at this section. Next, sine convention for shear force SF. Suppose this is any body. When shear force is clockwise direction is positive, it signs this is left or right, and positive and counterclockwise, this is negative shear force. This is left side and right side. When suppose this is negative shear force, suppose this is beam, suppose this is a beam, here the load is upward direction, and here a load downward direction, here is load downward direction, here load is upward direction. Suppose take a section, and for left side upward, left side upward positive, here shear force is positive, and for next, suppose wipe this section and take section from this is A point, B point and C point and D point. Take section here. Here is positive shear force, and left side downwards, left side downward, counterclockwise. This is counterclockwise. Clockwise, anti-clockwise. This is counterclockwise. And the left side, the section left sides at B point, the load is downward. My left side downward force is negative, so here shear force is downward, and suppose we at D point take a section here, the section, the right side upward is negative shear force. Understood the sign convention for shear force? The sign convention for bending moment. This is sagging. Initially the beam was straight. When the bending moment act here, this is sagging or concave, and this is positive, sign of bending moment positive, and hogging case negative, the sign of bending moments. Here first you can describe the sagging and hogging by the center of curvature. What is center of curvature? Suppose at sagging any 2 points, suppose this is sagging condition, the beam position is sagging. Suppose take sagging, suppose take any 2 points here and here and draw tangent here, draw tangent, and draw normal to the tangent at that point, and and join them. This is center of curvature. For center of curvature for straight beam is infinite. There is any 2 points and the center of curvature for straight beam infinite. You can see, suppose this is positive x, upward positive y, this is positive, this is y, negative. Here for sagging, this is center of curvature, center of curvature. First draw any 2 points and then draw tangent and in normal, and draw normal of the normal at that point and join them and get the center of curvature. And for sagging, center of curvature lies positive y direction. And for hogging, suppose this is hogging any 2 point and draw tangent and then draw normal, and for hogging center of curvature lie negative y direction. Understood the sign convention for bending moments. Next topic, how to calculate shear force and bending moment. You can see in the next lecture.